Welcome to part 3 of the video on iteration by parts. In this video we're going to introduce the LIATE rule, and we're going to talk about another trick that you can use with iteration by parts. What is the LIATE rule? We've seen that iteration by part is not hard. It isn't hard at all. The only thing that can be a little harder is choosing u of x and v prime of x correctly. Because if you don't choose these functions correctly, your integral won't simplify and you won't be able to solve the integral. So the LIATE rule is a rule of thumb that tells you which function you should choose as v of x. And the rule is in the order of the letters in the word LIATE itself. The letter L is for log function, the letter I is for inverse trigonometric function, the letter A is for algebraic function. An algebraic function is any polynomial function or the quotient between polynomials. The letter T is for trigonometric function, and the letter E is for exponential function. And the rule is that you should choose u of x as in the order of priority that the letters appear in the word. For example, if in an integral you have a log function and a trig function, the L comes before the T, so you should choose u of x as the log function. Let's see how this works in an example. Here we have the integral of x times sine of x dx. We already solved this integral in the previous video, and let's apply the LIATE rule to this example. Here we have an algebraic function that is x and a trigonometric function that is sine of x. So we have an A and a T. In the word LIATE, the letter A comes before the T. So we choose u of x as the algebraic function, that is u of x equals x. And this is how we solved this integral in the previous video. Let's see another example. Here we have the integral of e to the x times sine of x dx. In this case we have an exponential function, we have an e, and we also have a trigonometric function sine of x. In the word LIATE, the t comes before the e, so we choose u of x as the trig function, that is u of x equals sine of x. Let's solve this integral to show that this really works. We choose u of x equals sine of x, so v prime of x should be the other function, v prime of x equals e to the x. We calculate u prime of x, that will be cosine of x, and v of x, that will be e to the x. Now we simply replace in the formula of integration by parts. Here e to the x is v prime of x, sine of x is u of x. Here we have that this equals v times u. Here v of x equals e to the x, and u of x equals sine of x, minus this integral, the integral of v of x times u prime of x. Here v of x is e to the x, and u prime of x is cosine of x. So what we need to do now is to solve this other integral that is here on the right side of the equation. And to do that, we're going to use integration by parts again. We're going to apply the LIATE rule. Here we have an exponential and a trig function. The t comes before the e, so we choose u of x as the trig function, that is cosine of x. We have u, v prime of x will be v. Remember that we are now solving only this integral. We need to forget about the u and v that we use in the other integral. So u prime of x will be minus sine of x, and v of x will be e to the x again. Now we're going to apply the formula of integration by parts to this integral. where e to the x is v prime of x and cosine of x is e of x. Here we apply the formula inside this bracket. By the formula, this integral equals v times u, where v equals e to the x, u equals cosine of x, minus the integral of v times u prime. Here v equals e to the x, and u prime equals minus sine of x. So we can write this equation like this. Here we have another integral again, but here we can observe that these two integrals are the same integral. They are the same integral, the integral of e to the x times sine of x. So we can treat them as a number, as in algebra, and you can add this integral to both sides of the equation, because we're trying to solve for this integral. This is the integral that we want to find out. So we add this integral to both sides, and on the left side we get 2 times the integral, and on the right side we get, instead of the integral, we get 0. We can factor the e to the x in this expression, and we now divide both sides by 2, and get that this integral equals this function plus c, and that's the answer. And this is in fact an example of the other trick that I wanted to talk about. The trick is that when you apply integration by parts more than once, there are some cases in which the integral that you get on the right side would be the same that you get on the left side. In that case, you can do what we just did. We can solve for the integral. You can treat the integral as a variable in an equation and solve for the integral to get to the answer. So that's all for now. Thank you for watching, and see you next time.